Hello, ladies and gentlemen. Today we'll be talking about dimensional analysis. Dimensional analysis is a systematic problem-solving technique. I should probably write the title here, dimensional analysis. So this is a systematic problem-solving technique. We've seen this a few times in class before. I believe that we ended our last class period with discussing this a little bit in some of the class periods. This method is particularly useful when doing any sort of conversion using the English system of measurement. So whether the conversion is all in the English system or you're asked to convert either from SI units to English units or from English units to SI units. And dimensional analysis makes use of conversion factors, which are also called equalities. And an example of a conversion factor or an equality would be 1 foot is equal to 12 inches, or 1 inch is equal to 2.54 centimeters. We use these and multiply and divide by these conversion factors or equalities in order to perform the conversion. So here's an example of a problem that we could solve using dimensional analysis. Now, I know I've showed you guys two different ways of expressing the math that you're doing during dimensional analysis. So I'm going to show both ways this time, and then in the next example, I'm only going to use one way. So the question says, a cross-country race is 5 kilometers. If 1 mile is equal to 1.609 kilometers, how many miles is the race? So the first thing I'm going to do is identify what problem, or rather what question, not what question, which number is being converted here. So 5 kilometers is what I need to convert. Then I'm going to identify my equalities and I'll write them down. 1 mile is equal to 1.609 kilometers. So what I'll write down here is 1 mile equals 1.609 km. Now I need to start this problem using the number which will be converted, the 5 kilometers. So I'll start with 5 kilometers. And what I need to do is I need to use my conversion factor here, and I need to make sure that my units cancel. Kilometers divided by kilometers is 1, and anything multiplied or divided by 1 is just itself. So if we divide by kilometers, then those units will cancel each other out, and I'll show that in a moment. And 1.609 kilometers is equal to 1 mile. So if we do this, get the calculator out here. 5 miles times 1 divided by 1.609 kilometers is 3.1075202 miles. But if we look at our significant digits, we would not want to use the significant digits in our conversion factor. We would want to use the significant digits from the number we started with. There's only one significant digit in 5 kilometers, so our answer actually ends up being 3 miles. We would round our answer to one significant digit. An important step is making sure that your units cancel. And what I mean by that is I don't want kilometers anymore, so I need to at some point divide kilometers by kilometers, and I need to at some point multiply by miles in order to get the correct units in the end. Now, how this could also be shown is using multiplied fractions. So we could also write 5 kilometers over 1 times 1 mile over 1.609 kilometers. The units still cancel, still left with miles, and I still get 3 miles with significant digits as my answer. Now, this would be a good thing to take notes on, the steps we would use in order to solve a dimensional analysis problem. Step 1 would be to identify the number of, or rather the measurement that is to be converted. So in the previous problem, that was 5 kilometers. And then step 2, we would want to identify the desired units of the answer. So, okay, we're starting with 5 kilometers. What am I supposed to express that in? Well, in the last question, that was miles. So I need to figure out a way to get kilometers into miles. And that's where step 3 comes in, right here. Identify the conversion factors needed. In some cases, you'll be given a list of conversion factors. You need to find the conversion factor or factors which provide a route from the starting number to the measurement, or rather to the unit that you need for your answer. Once we have those, we would set up fractions like we did in the previous problem, check that all units cancel with the appropriate units remaining in the end, and then we would go ahead and do the math and round at the end using significant digits. And probably we would want to say go back to this step at the end and make sure, again, that all your units canceled and that the appropriate units remain. So we'll try one more problem. Example 2, a weightlifter deadlifts 200 kilograms. How many pounds did the weightlifter lift if 454 grams is equal to 1 pound? So the first thing I'm going to do is I'm going to identify the number that's being converted. And that measurement is 200 kilograms. Then I need to identify the units that my answer should be in, and that would be pounds. Now I need to find equalities or conversion factors that I can use, and one is given in this problem. 454 grams is equal to 1 pound, so I can write that. 454 grams is equal to 1 pound. Now, my units that I start with are kilograms, not grams. So I also need to know a conversion factor that can take me from kilograms to grams. If you're comfortable, you could simply convert kilograms to grams before even starting the problem. Or we could think about our metric ladder and we could figure out how many grams are in a kilogram. And if you do that, you'll see that 1,000 grams are equal to 1 kilogram. And now we have all of the steps, or rather all of the conversion factors that we need. Because we're starting at kilograms, we can go to grams, and then we can go from grams to pounds. So now we'll set up our problem. We're starting with 200 kilograms. Setting up our fractions. 200 kilograms. I need to divide by kilograms in order to cancel my units. 1 kilogram is equal to 1,000 grams. And now I need to divide by grams in order to cancel that unit. 454 grams is equal to 1 pound. Whoops, there we go. Now I need to go back and make sure that all my units cancel. Kilograms cancel with kilograms. Grams divided by grams, that cancels. And I'm left with pounds as the unit in the end. And the question asks me to solve for pounds, so that is appropriate. Now I'll take my calculator and I'll multiply 200 by 1,000, which gets me 200,000. 200,000 divided by 1 is still 200,000. Multiplied by 1 is still 200,000. And then divided by 454, that should be 440.528 pounds. But I'm not done because I need to check my significant figures. So if I look at the original number, right, because I wouldn't want to use my conversion factors to limit my significant figures, 200 kilograms, that decimal point means that that last zero is significant, as is the middle. So I have 3 significant figures. I'm allowed 3 significant figures in my answer. So my answer is 440 with a decimal point pounds. Or if you're more comfortable, you can put it in scientific notation, 4.40 times 10 to the second pounds. Now, if you need to go back and watch this video, I posted the link on Teams. You should have some problems to work on in the meantime, so go ahead and start working on those, practicing dimensional analysis. Now, I know that some of those problems you could probably do in your head with a calculator, but I want you to practice setting up your problems, setting up your dimensional analysis like this, or using the fractions multiplied by each other. I don't mind either way you want to do it, but practice setting it up so that you can practice canceling out those units, because that's going to come in handy much later.